Hello. Today we will be discussing how to analyze, interpret, and write your results sections for your APA style papers. Um, so let's just get to it. Um, so we have several different tests that I'm going to be discussing today in terms of how to interpret them and report them in your APA style section. I'll also be going over just kind of what should be included in your results and discussion sections. So to start, some of the different tests that we have are t-tests. There are several different kinds of t-tests, and primarily you guys are dealing with independent and dependent samples t-tests. But typically, t-tests include one categorical independent variable that has two levels or two conditions. So it can be our class and Greenwood's class. That would be two conditions or levels of the independent variable of class or professor, whatever. And a continuous dependent variable would just be something that we're measuring them on. So an example of a continuous variable could be test scores. Continuous variables typically can include decimals. So your test score, if I were to average them all together for our class, could be 76.4 or something. These can be numerical. These can be, typically you have decimals when you have numeric variables when we're talking about. But ultimately, typically with t-tests, you have one categorical variable and one continuous dependent variable. You can also think of it as one quantitative variable. So you have a categorical and you have a quantitative variable, but your categorical variable is typically your independent variable, and that can be split into two different conditions or levels. So a one sample t-test, we're looking at a sample and a population for a different, we have a sample that we're comparing to a different population. So the sample that we have is obtained from a completely separate population, and we're trying to see if the population for our sample is approximately hypothesized to have the same mean as the population provided. We're not really doing that in 144. We're not really doing that in research methods, at least for our projects, because typically we don't really have access to population data. I mean, we could, but for the sake of our projects, we don't really use population data. More so, we're generalizing our samples to the population. So the next two, independent and dependent samples t-tests, this is more so what we're working with in our class. So this could be, is the sample mean for one group different than the sample mean for another? So you can have, if you guys are going to be conducting an independent samples t-test, your sample means are just the means of your two conditions of your dependent variable, typically measured quantitatively, continuously. So you can be comparing, I always use like our class compared to Greenwood's class in terms of test scores. Maybe you have conditions where you're motivating people and you're not motivating people. You just kind of leave it a control condition and you're seeing, how does their self-efficacy change? If they're exposed to a motivating condition, you are going to split your groups into those who received the motivating experimental condition and those who did not, and compare their efficacy scores between them. You can be looking at a multitude of different things. So you can have, I'm going to show you only attractive faces and judge your self-worth and measure your self-worth. And I'm going to show you only neutral or even unattractive faces, and then I'm going to measure your self-worth, and I'm going to compare these two groups. That's assuming that no one gets both. So people aren't exposed to neutral or unattractive as well as attractive faces, but they're only exposed to one or the other. Independent samples t-tests typically use a between subjects design that makes sure that the two groups you're comparing are in fact independent of one another. They're two completely separate groups of people. Maybe if you have 100 participants, 50 see the attractive faces only and 50 see the unattractive faces only, what have you. So a dependent samples t-test, it still has two conditions. But typically the people that are in dependent samples t-tests, the participants that you're analyzing, they have been exposed to both. So you're going to see, let's look at those attractive and unattractive faces again. So instead of half the participants only seeing attractive and the other half only seeing unattractive, for dependent samples t-tests, all groups or all people, all participants are seeing a mix of attractive and unattractive faces. And then you want to see the differences between their self-worth or whatever it is that you're measuring. But you want to see the differences for each individual person, comparing those two groups of when they saw the attractive and the unattractive faces. The only difference really is that instead of the two groups being 50 and 50 different people, it's two groups, yes, but it's all the same person or the same group of people being exposed to both conditions. So I know we've had an in-class activity that kind of triggered, or not triggered, but kind of looked into which statistical test you'll be using. And I know I've given feedback to you guys, so hopefully it seemed like a lot of you guys were understanding which inferential test you would need to use. Either I noticed pretty much independent or dependent samples t-tests across the board. But just knowing which test to use is going to make it easier for you when you start analyzing your data, when you start writing your results, because then the results will make sense. And you'll at least know, oh, okay, all my participants were exposed to both conditions, so I know I'm going to use a dependent samples t-test. I know how to go from there. So other tests that are used in statistics and research methods are ANOVAs. So this is an analysis of variance. It's an acronym for analysis of variance. This is where you have a categorical variable. You can have more than one categorical independent variable. But the difference here is that you have at least 3 conditions or levels of that independent variable. So we can compare our class, Greenwood's class, and Dr. Burtkin's stats classes. We can compare it that way. That would be an ANOVA. Those are 3 separate groups, 3 groups overall, and we're comparing test scores between them. So we have a one-way ANOVA, repeated measures ANOVA, and a factorial/two-way ANOVA. So with a one-way ANOVA, this is where we have only one independent variable, so class, right? And 3 unrelated groups. So our class, Greenwood's class, Burtkin's class, no one is in more than one group. No one is also in, or I'm using stats examples, I apologize. So our class, Greenwood's class, and another 144 professor would be Dr. Price. So, you know, you guys aren't registered for 2 of the same class in the same semester. So those would be unrelated groups because there's no overlap. There is no student who is in my class as well as Greenwood's class, as well as Dr. Price's 144 class in, you know, spring of 2020. So these are independent. It's similar to an independent samples t-test, except now we're just tacking on an extra group, an extra condition. So another type of ANOVA would be a repeated measures ANOVA. So this is similar to a dependent samples t-test. So a one-way ANOVA is similar to an independent samples t-test, just adding on an extra condition. A repeated measures ANOVA is similar to a dependent samples t-test, but again, we're adding on another related group. So, you know, we can have a group of 100 participants being exposed to some type of treatment, maybe a diet, maybe like it says in this example here, maybe yoga, and we measure their well-being, their flexibility. We measure something at 1 month into this training regimen, 3 months in, and 6 months in. We measure their well-being for each of those time periods. Well, it's the same group of 100 people doing this treatment of yoga or, you know, a diet or an exercise or whatever. And we're looking at their differences in a continuous dependent variable, a quantitative variable at 1 month into this program, 3 months in, and 6 months in. If it was a dependent samples t-test, we might just go with 1 month in and 6 months in or something like but with ANOVA, with a repeated measures ANOVA, we have 3 different time points in which we're measuring. So a factorial or two-way ANOVA is where we have multiple independent variables. So with everything that we've discussed so far, we've been only dealing with main effects. Remember that a main effect is present when you only have one independent variable. You see, oh, you know, our class did better than Greenwood's class. We have a main effect, a statistically significant main effect of our class did better on their test scores overall. So we did have a main effect here. But we have, with factorial or two-way ANOVAs, we have the possibility of having interactions, because now with these types of ANOVAs, we have more than one independent variable, which is when interactions can become present. It's not necessarily guaranteed that you'll have an interaction if you have multiple independent variables, but the option is there. It is a possibility. So practicing yoga and eating vegetables have an effect on calmness. Maybe people that practice yoga overall just, oh yes, anytime you practice yoga you have an increased calmness. But when you also eat vegetables, that's like boom, your your calmness is skyrocketed, whereas with all the other conditions, maybe it's not so much. All the other combinations of conditions, it's not as high. So again, I didn't notice any ANOVAs in the analysis in the in-class activities, but it's still good to know that an ANOVA is pretty similar to independent samples t-test or dependent samples t-test, but with a tacked on condition. And then factorial or two-way ANOVAs, that is where interactions begin to take place, or at least they could. So we also have Pearson's R and correlation. So this is where we have two continuous variables or two quantitative variables. So this is both a measure of effect size and it is a null hypothesis test statistic. So we have Pearson's R, we had our measurements of, we had the direction to where if your Pearson's R value is positive, it is a positive relationship. So both variables go up together, or they tend to go up together. And a negative Pearson's R is as one variable goes up, the other is likely to go down. And then we have the number itself of Pearson's R. So 0.1 around that region is considered weak or small, 0.3 is considered medium, and 0.5 is considered strong or large. That refers to the effect size. And the null hypothesis is where we test to see if this relationship is actually present in the population. So we have the example here of, does alcohol consumption decrease memory? So we take, we give 100 people the survey of, kind of measuring how much alcohol they consume and perhaps giving them some sort of memory test, maybe a short-term memory test, a long-term memory test, words, however we want to measure memory, we give them that measure of memory. And we can conduct Pearson's R with it. But then as we do this, we have the effect size of, oh, maybe our Pearson's R is negative 0.3 or something. As alcohol increases, memory retention tends to decrease. So the more alcohol you consume, the less likely you may be to remember things. We can also say, by conducting a null hypothesis test, hey, the null hypothesis is saying alcohol consumption and memory have nothing to do with one another. They're just two, separate coins of separate change purses. I don't know. But if we reject the null hypothesis, that's telling us that, hey, in the population of all Americans or all college students or whatever our population is, in the population, it seems to be a trend. There seems to be a relationship where the more alcohol you consume, the less likely you are to remember things or to retain information. So we don't really have independent variables with Pearson's R. In fact, there are no independent variables with Pearson's R with correlation, because correlation does not imply causation. It's a correlation because we haven't manipulated anything. So Pearson's R does not have any independent variables. In a way, it kind of has two dependent variables. So another one, so we've talked about t-test and ANOVA, which have categorical independent variables, where t-tests have two conditions, ANOVA has three. Excuse me. We've talked about Pearson's R, which has two continuous or two, quantitative variables. Now we have chi-square. That is where we have one or two categorical variables that we're looking at. So when we have one categorical variable, it's called a test of goodness of fit, a chi-square goodness of fit test. And this is just kind of looking at an observed frequency of this categorical variable's conditions and seeing if it differs from a theoretical distribution. So if we're going to look at t-shirt sales at Target, you know, every size t-shirt sold equally at Target. So you have extra small, small, medium, large, extra large, you know, maybe extra small, extra large, etc. The null hypothesis for that test would say, oh, yes, every single shirt size is sold at an equal proportion to the other. So if you have 2,000 shirts sold at Target of a particular shirt brand or whatever, each size will be selling the same amount. But with that goodness of fit, with that chi-square, it's likely that no, shirt sizes will not be all, you know, equally distributed across the board. Maybe you'll have more mediums and larges being sold out. Maybe you won't have as many extra smalls or extra larges being sold or whatever. But a goodness of fit test is looking at an observed frequency of one categorical variable. And again, that categorical variable of t-shirt size is split into different categories. So we have the different sizes of t-shirts. Now next, a test of independence, a chi-square test of independence, is looking at two categorical variables. So we're trying to see if they're related to one another or if they're independent of one another. So let's say we're trying to see if there's a relationship between people who drink coffee or people who drink tea. A categorical variable, again, you're either a tea drinker or a coffee drinker. You can't be a little bit of both in terms of how we're going to categorize this data. So we want to see if there's a relationship between coffee drinkers and tea drinkers, and maybe to see if there's a relationship between these type of drinkers, and if they prefer Xbox or PlayStation or Netflix or Hulu or whatever the hell. Maybe we see, oh, coffee drinkers tend to prefer PlayStation. Oh, that's interesting. We'd expect there to be an even distribution throughout all those groups, but it turns out a lot more coffee drinkers tend to prefer PlayStation over Xbox or something. We're trying to see if these categorical variables are just unrelated. If they're unrelated, they'd be probably equal in each kind of group that we have them in. Coffee drinkers prefer Xbox, coffee drinkers prefer PlayStation, tea drinkers prefer Xbox, and tea drinkers prefer PlayStation. But if there is a relationship there, we'd see, oh wow, coffee drinkers really like Xbox. So there's a larger proportion of coffee drinkers who like PlayStation than everything else. I might have said Xbox previously, but I meant PlayStation. Okay, so now that we kind of gone over the different types of tests, you know, we've talked about t-tests, independent and dependent, ANOVAs, one-way, repeated measures, factorial / two-way ANOVAs. We've talked about correlation. We've talked about chi-square. Now here's the point, the process of, okay, so how do we report these results? You know, once you guys have analyzed your data, you'll see, okay, cool. You know, I got my p-value, I have all my information. You know, I have my test statistic. I know what to do about my hypothesis. Maybe you guys have statistical significance. You're like, oh my God, our hypothesis was, you know, supported by our data. That's exciting. And it is exciting. But you got to know how to report that in APA style. So this here is just a breakdown of what I've discussed of each bullet point represents a different test. So that first one of T39 equals 3.16, P equals 0.003, that's reporting a t-test. Now that can be the same for dependent and independent samples t-tests. You have your degrees of freedom in parentheses, your test statistic. So for a t-test, that would be your t-test statistic, and your p-value. Now that's pretty much the same down the board here. The F227, that is an ANOVA. So ANOVA uses an F statistic. And those two numbers, the 2 and 27, refers to the degrees of freedom. There are 2 degrees of freedom with ANOVA. but it also says equals the test statistics, so whatever your obtained F value was and the P value. You have R, that's going to look at Pearson's R, your degrees of freedom, your R statistic, and your Pearson or your P value. Your chi-square, that is the x squared, although that should be chi, the Greek letter chi. 2 is your degrees of freedom, and then your n, your total sample size, and it pretty much equals test statistic, comma, p value equals whatever. So remember, just as a reminder, we typically set alpha at 0.05. That 0.05 is what we compare our p value to. So if our p value is less than 0.05, we would reject the null hypothesis. That means that we have statistical significance. So for all of these examples, we would actually reject the null hypothesis. 0.003 is less than 0.05, 0.021 less than 0.05, 0.012 less than 0.05. And obviously, if your p-value is stated, if your p-value is super low, sometimes you'll report it as it is less than 0.01. And obviously, if it's less than 0.01, it's going to be less than 0.05. So this is just kind of a look at what t-tests, ANOVAs, correlations, and chi-squares look like just in the formula that APA requires when you report the results. So with the numbers, you'll need to report your means and standard deviations for your groups. So, you know, oh, the mean for Professor Cooper's class was 72 with a standard deviation of 5.2, and the mean of Professor Greenwood's test scores for his class are 70.1 with a standard deviation of 6.2 or whatever. You need to have that. You need to know which test you're using so you know how to report it. So it's a t-test, you're gonna go with the T. F, that's gonna be ANOVA. R, that's correlation, and that chi-squared, well, that's chi-squared. You need to know your degrees of freedom. You need to know your p-value, your effect size, which again, if you're doing a t-test, be it independent or dependent, the effect size that you're going to use will be Cohen's D. If you have correlation, you will be using Pearson's R. As a general rule though, any letter is italicized. So just to kind of go back to this, you'll see that the T, the F, the R, and the chi are all italicized, as are the P. When we report Cohen's D or any effect size, we will also put the letter D or R if you're doing correlation. Those will also be italicized. Okay, so here's an example for a t-test, although I'm going to go to, well, okay. So you'll notice when you get readouts, when you analyze your t-test, your independent or dependent samples t-tests, you'll see this information. And I've provided a Word document to the TAs, so they can also show this to you, or a PDF, kind of walking through a dependent and independent samples t-test. And it concludes with pretty much what I'm going over right now. So when you have your readout, you're going to have numbers here of, oh, the degrees of freedom is 7. The t-stat, because this is a t-test, this is a 2-sample assuming unequal variances test, so that's basically independent. Your t-stat is 1.47. Your p, a 2-tailed, you want to look in the 2-tailed section of p, and that gives you your p-value. So pretty much when you have a t-test, when you have the output, I should say, these sections here that I have circled here or squared here, whatever, those are the things that you need to be concerned about. You don't need to worry about the hypothesized mean difference. You don't have to worry about the P for 1-tail, the critical value for 1-tail, or the critical value for 2-tail tests. You're only looking in terms of what you need to put in your APA style paper. You're only looking at the degrees of freedom, which goes in the parentheses here. I have the same color, sort of. It's kind of, I kind of use gross colors, I apologize. But you're using the same color. So this, I don't know, greenish box is what is depicted here in parentheses. So T, that T never changes. That italicized T doesn't matter. That's going to stay there. That goes there. So this 7 goes here in the parentheses, equals your T statistic. So that would be 1.4726. Again, since this is rounded, since this is APA, we'll round it to 2 decimal places. So that gives us 1.47, comma, we're going to look at the P for a two-tailed test, and it's 0.184. So that P value is definitely greater than 0.05, or you can put equals 0.18. That would be fine as well. So when we have, when we're reporting this, you can kind of use this as a template for you to write about it. One of the things you want to write in your results section is you don't want to just say, oh, you know, here's our stuff, we reject the null hypothesis, moving on to the discussion section. You kind of want to have a sentence or two that describes what it was. So if you're doing an independent samples t-test, you can say, oh, an independent samples t-test was conducted to compare whatever your dependent variable is. So to compare test scores in IV level or condition number 1. So to compare test scores in Professor Cooper's class and Professor Greenwood's class, those conditions. So another example here is independent samples t-test was conducted to compare memory, the dependent variable, for words in sugar and no sugar conditions. So participants are provided sugar or they're not provided sugar. So you can say if you, you know, regardless of if you have significance or not, you can start with this next bullet point. There was a significant or not significant if you didn't reject the null hypothesis. There was a significant or not significant difference in the scores for Professor Cooper's class. We've stated that as the level 1. And then you can report the means and standard deviation. So 72.4 and the standard deviation of 5.2. And Professor Greenwood's class, mean of 70.1, standard deviation 6.2, or whatever I said those numbers were. And then you can report T degrees of freedom equals T statistic, comma, P value. So to kind of put it together, there was a significant difference in the scores for sugar. Again, this is looking at this example here. We have the sugar and no sugar conditions. So there was a significant difference in the scores for sugar. Then you just plug in your means and standard deviations there. And no sugar, plug in your means and standard deviations there, conditions. And then you just simply state your t-test results. So you'll see that, yeah, their p-value was less than 0.05. So yeah, to say there was a significant difference in the scores for sugar and no sugar conditions would be accurate because they rejected their null hypothesis. So in case you're going to be doing a NOVA, although it doesn't really seem like anyone will be, but just to kind of go over it quickly, this is comparing 3 different conditions, 3 different majors, and looking at their salary. So we have an we have F 222. So again, in the parentheses, it's always going to be your degrees of freedom. So the 2 and 22 refers to between and within groups degrees of freedom. Between comes first, within comes second. Equals, here is your F statistic that you have calculated. So don't pay attention to F critical when you're reporting your ANOVA results in this format. So we round that to 15.20 since this is 15.196. And then our p-value is certainly less than 0.001 because that has many negative exponents. So again, I've color-coded this to show you where these numbers go. So again, this is just another template to kind of plug in the information for your study, for your conditions, for your dependent variables into a format that's palatable for APA. So one way between subjects ANOVA was conducted to compare the effect of sugar, of your independent variable, on memory for words in sugar, little sugar, and no sugar conditions. So we have 3 different conditions of the sugar consumption, and we're still looking at how that is affecting memory. If you have significance or not, again, here's the little breakdown of there was a significant or not significant effect of sugar or whatever of class on test scores. Maybe, you know, on Professor Cooper, Professor Greenwood, Professor or Dr. Price. However, when you reject the null hypothesis for ANOVA, you'll need to conduct a post hoc test. You'll need to report the post hoc test because a post hoc test is essentially telling you which groups are different from one another, which group is higher, which group is lower. Maybe our class, maybe we had an ANOVA and we rejected the null hypothesis for test scores between our class, Greenwood's class, and Dr. Price's classes. However, with ANOVA, it's not going to tell you, oh yes, Dr. Price's class scored way higher or way lower than Greenwood's or whatever. It's just telling you they're different, but we don't know which one's higher and which one's lower. And that's what a post hoc test would do. That's going to kind of break it down and say, okay, so yes, not all the means for each group are equal, but here's where they're really different. But you only need to do a post hoc test if you reject the null hypothesis for ANOVA. Anyway, so here is correlation. So we have hours studied and exam grade. So we're just looking at the correlation between how many hours people study and their exam grade. And again, I have it labeled here to where R is broken down to how many, let's see, 1, 2, 5, 6, 7, 9, 10, 11, 12, 13. Okay, so your degrees of freedom is R minus, or is number of people minus 2. So you have 1 person, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, minus 2, that gives you your degrees of freedom there. Equals, here you're gonna have your multiple R. So this is a regression. So that is equal to 0.86, and your p-value is reported here. Again, I don't think that you guys are going to be doing correlation. In fact, for this project, correlation should not be your primary inferential test that you use. But if you want to do above and beyond and include correlation, you can. And here's the template for that as well. So Pearson's correlation was computed to assess the relationship between hours studied and you know, exam scores, or between violence and ice cream sales, or whatever. And then you just report the information from the previous, using the previous slide as kind of an example, as a help. Chi-square, again, I'm not going to get into too much detail, but in terms of what you need to have, again, the degrees of freedom is in that parenthesis. The total number of people is 175, so that is just the total number of people there. And we're looking at income bracket and education. So you have your chi-square, you have your test statistic there at 15.81, your p-value right there, and those are reported. And here's the template as well. I'm going to be posting this on Canvas if you're interested in looking into more of this, but I really want to focus more so on reporting or analyzing the data, analyzing and writing your results section. So again, these are the different ways to report your p-value. You can just do equals, whatever. If it's really tiny, like how we had where it had a negative exponent, you can definitely just say p is less than 0.001 or 0.01. And we've already gone over this because we've had that in-class activity, but in case you kind of want a little, just another little look or just kind of a chart to use, this is how you would determine which type of inferential test to use. So you have how many levels are there to your independent variable. Oh, if there's 2, you could use a t-test. If it's a categorical independent variable, categorical. Yeah, and then the continuous or quantitative, oh, that's a t-test. You know, we had a categorical independent variable of, oh, which class are you in, basically. We have 2 levels, our class or Greenwood's class, and we're going to compare test scores. Oh, we used a t-test. Now, if our oh, I want to compare the class, we're going to look at what class you're in again. Now let's use ANOVA. Instead, it's our class, Greenwood's class, or Dr. Price's class. We're going to, again, compare test scores, et cetera, et cetera. And these are just the different types of tests there are. We have one-way independent or dependent samples, t-tests. We have one-way, two-way repeated measures, ANOVA. And for chi-square, we had goodness of fit for one categorical variable and test of independence for two. Okay, so now kind of looking at, I'm going to talk about how to write your results and discussion section. So for your results, it's going to be fairly short and straightforward. You don't have to get into a really wordy description. You can just be to the point. Again, I mentioned how APA style is really about being straightforward, being upfront, and just describing what happened. The results section really needs to follow that. Since APA style, since psychological research tends to have a lot of statistics in it, the style of writing that we use is really values that straightforward, cut through the crap and just tell me what I need to know. With that being said, there are certain things you may need to make sure you mention. However, you don't have to go about it in a really roundabout, like, oh, the rain in Spain was on the plane this morning when I did my independent samples t-test. Like, nah. So it will have a lot of numbers in your results section. Try not to let that intimidate you, although I know that you guys have expressed concerns about the results section. And I'm going to talk to APA. No, I'm going to talk to Simran and Javier to see what we can kind of figure out for that. However, things you need to have in your results section. So if you need to have information on your data itself, on the process it took to get to the point to analyze it. So did you have to exclude any data? Like, did you have to remove any participants because maybe they didn't finish their surveys, maybe you can tell they weren't taking it seriously or whatever? Make sure you state that. Make sure, oh, we had to remove 3 participants' data because they didn't take it seriously or just because they didn't complete the questionnaire. Did you have to reverse code anything? This is something else that you'll want to fill in the blanks on. If you have a question, a survey on happiness, let's say, and it's all like 1 is not happy and 5 is very happy, and suddenly you have, or 1 is strongly disagree and 5 is strongly agree, and most of your questions are, I find myself happy all the time, strongly agree, 5, and then you have, a 5 there represents you're very happy. And then you have another question that's saying, oh, I find myself crying constantly because I can't stand how sad I am or whatever. If you strongly agree to that, 5, I'm constantly crying, well, that's not really meaning the same as, strongly agreeing to happy things. You're actually strongly agreeing to unhappy things. So those are the kind of questions that you'll want to reverse code, those strongly, or those ones that kind of break the mold. So all of your questions were happy, and 555 means you're super happy, super happy, super happy. Then you have a question asking about how unhappy you are. Obviously, a 5 on that is not going to represent being very happy. A 1 on that would actually be very happy. Strongly disagree with I cry all the time is saying, hey, you're not crying all the time, obviously. So did you reverse code? And how did you score your surveys? One thing I want you guys to know is, did you have a composite score, which you guys will. You had multiple questions relating to your variables. You need to make sure you state, hey, we had 10 questions measuring motivation or 10 questions measuring self-esteem. What we did was for each individual participant, we took a composite score. So we just averaged or sum, whatever you prefer. We took their composite score of each individual person. So we had a self-esteem scale on a 1 to 5. We used a 1 to 5 scale for self-esteem. And, participant 1, we found the average overall self-esteem for them, 3.2, and we did the rest of them. You don't have to say each individual's composite score, but you do need to mention how you turned, in your method section, you say, oh, we had a 10-question survey on self-esteem. And then in your results section, suddenly you're just reporting means and standard deviations. And the reader is kind of left with, okay, what is this the mean and standard deviation for? Is this for each question? Is this for one question, or you're just screwing the other 9? You need to state in your results section, hey, remember those 10 questions I said that was going to measure self-esteem? Well, we averaged those together for each participant, and then we took the average of the averages, and that's how we got this final means and standard deviations for overall self-esteem, etc. So you need to discuss your primary research question. So whatever your hypothesis was, we all have the hypothesis for our projects where, oh, I think that people who are highly motivated are going to have higher self-efficacy, or people exposed to motivation will have higher self-efficacy, or I think people that are exposed to, or I think that I think attractive faces are going to elicit higher levels of self-worth. Or maybe it's the opposite. Maybe unattractive faces actually elicit higher levels of self-worth, and the attractive faces elicit lower levels. I don't know. You all had your hypotheses as to what you thought was going to happen before you started collecting data. So make sure that you report the results of that, which is just essentially saying, report the means and standard deviations for your 2 conditions. Again, because most of us, if not all of us, are doing an independent or dependent samples t-test. So report the means and standard deviations for them. Make sure the inferential stats are reported. So that's, what I've shown you guys how to report the inferential statistics earlier in this PowerPoint. Excuse me. So just go back to that and use that as a reference. Again, you can also use the PDF file that I've provided with Simran and Javier to help you with not only getting your dependent or independent samples t-test completed on Excel, but also how to report it, what to look for in your readouts to know what to do. Next, you'll also want to mention the significance and the direction of it. So again, you will be needing to report Cohen's d, so you'll need to say, oh, okay, what is your Cohen's d? And in terms of the direction, that's really more so which group scored higher. Okay, so if you have any secondary research questions, although given the fact that this semester has kind of been a mess, just a smidge, I'm not really as concerned with any secondary research questions you have. If you still want to include them, that's up to you, that's fine. But if you're really just thinking, I'm not doing any more data analysis than other than the independent or dependent samples t-test I signed up for, that's fine. But one thing you'll have to do is make sure you include a table or a figure, more so a figure, which is essentially just a bar graph. Just include a bar graph, since we all have independent or dependent samples t-test, and that those graphs are going to depict the means in each of your conditions. So again, this is just discussing if the data exclusion is saying remove people, you had to remove them because they didn't follow instructions, or they were not taking it seriously, they didn't finish it, whatever. Just make sure you state, we had to remove X amount of participants because they did not follow instructions or something. You don't really have to get too into detail. You don't have to say, yeah, they filled out gender as I'm a Tonka truck and they weren't taking it seriously. I've seen that before. But you don't have to say why exactly, like they didn't finish 9 out of the 10 questions that we provide. You can just say, hey, we had to exclude 3 because they didn't finish, or we had to exclude 3 because they didn't follow instructions. That's all that needs to be said. Excuse me. So again, you need to calculate your overall variables. So this is the means and standard deviations for them. But before you do that, you kind of need to state how you got there. So how did you score this questionnaire? 1 was strongly agree, 5 was strongly disagree, or vice versa. How did you pull them all together? So we had 20 or 10 questions measuring our dependent variable, and now we're left. I'm going to talk to you about the means and standard deviations for each condition. How did you get there? Explain your composite scores. Explain we found the average or the sum for each individual participant in their self-esteem scores or self-efficacy scores or self-worth, or whatever your dependent variable is, whatever it is that you're comparing between your groups, and just say how you turn that into one thing instead of a questionnaire of 10, which again is done just by making a composite score. Excuse me. Okay, so the descriptive statistics, these are referring to your means and standard deviations. So again, like I've stated earlier, like I've shown earlier in the results, or in this slide, in this PowerPoint, excuse me, my God. There are ways where you can mention your means and standard deviations kind of seamlessly within the data, within your description of your independent or dependent samples t-test. But you do want to make sure that you report when I say central tendency and variability, central tendency pretty much refers to the mean, and variability pretty much refers to the standard deviation for this instance. You don't typically report any other levels for this type of thing. Okay, you'll also want to include a figure, like I said. So you'll want to include, you want to mention your figure in your results section. So we have, as figure 1 shows, and then, the means for attractive faces were much lower than the means for unattractive faces in figure 1, or something like that. Doesn't have to be too in-depth. Just make sure that you do mention that you have a figure within the results proper, within your writing. So here are the examples of figures. I say no color, but honestly, for your results sections, if I know that for when you make bar graphs in Excel, it tends to kind of default to that sky light bluish color. You can just keep that. I'm really not too particular, but typically proper APA style, no color. It's all grayscale to some extent. You have the description on the bottom. So I kind of refer to this as the caption. So you'll see that the description is figure X, so that X should be a number. So if it's the first and only figure that you have, that will just be figure 1. Figure is capitalized, and there is a period after the 1, and that entire part is italicized. So figure 1 is capitalized figure, and it's italicized, and then there's a period. And then it gets into the description of what is being shown in the figure or the graph. So you don't have any color. Again, I'm not really too particular. If you have the blue on it, it's fine. You will want to make sure that you have your axis labels. So, what is your x-axis? So here we have the, education, exposure, control. We have our x-axis labeled as condition, as well as the 3 different bars. And then you'll want your y-axis labeled as well. Now, I don't really like how it's vertically aligned here. I feel like it should be rotated 90 degrees, so you're not having to herky-jerky your neck to read it. But yeah, so this is how your APA figures should pretty much look. You only have the X and Y axis labeled. You don't have any of the grid lines in the middle. It's just blank space in the middle other than what your data is, what your data are. So yeah, that is pretty much APA figures in a nutshell. And if you have any questions, I'm sure that APA, or that, damn it, why do I keep calling the TAs APA? So you can talk to Javier or Simran. None of those sound like APA whatsoever. Also, if you can shoot it by me if you're still unsure, and I can check it over as well. So this we've just gone over in the first half of our little lecture here. The inferential stats, which null hypothesis tests were used? Did you use independent or dependent samples t-test, essentially? Did you use ANOVA? Did you use chi-square? Blah, blah, blah. You'll report that. And again, using that same format, you'll report the test statistic, degrees of freedom, and if the p-value was greater or less than 0.05. Again, previous slides in this same lecture have shown you exactly what I'm talking about for this slide, for this part of your results. So you want to make sure that you are clear about whether or not you rejected the null hypothesis. So this is saying, oh, we did find a significant difference, or there was not a significant difference. That's you being clear as to whether or not you rejected the null hypothesis. Okay, so the discussion section, this is an important part of your paper, and it's also can be really difficult to write. So you'll want to include the results without numbers. So it's just pretty much describing what had happened in English. You want to talk about the implications of it. So this is looking at the theoretical importance by referring back to the articles in your introduction. The practical importance, maybe you can relate to this in, you know, more real life settings, not just the theoretical. You will be using in-text citations for your discussion section if you're going to be referencing previous work in your intro, like previous articles you've already discussed. Anytime you mention the work of someone else, you're always going to use an in-text citation. So there should be in-text citations in your discussion, because part of your discussion is discussing previous research. And then you'll talk about the limitations of your study and recommendations for future research. So to start, I mentioned how your discussion section needs to just be the results in English. So this is just, you know, you don't have to rewrite the T degrees of freedom equals test statistic, comma, p-value. You don't have to do all that again. You don't really even have to report the means and standard deviations again. You can just say something as simple as, oh, our primary research hypothesis was reported by the results. It turns out that people exposed to music with pro-social content were more likely to act in a pro-social manner than those exposed to neutral music lyrics. Or, you know, those exposed to a motivational video our results were supported, or our hypothesis was supported. People that were exposed to a motivational video were actually reported higher levels of self-efficacy than people in the control condition. Something simple. Again, just what did you find? If you find statistical significance, say that. You can just say, oh, you know, the motivational video did better. The people reported higher levels of self-efficacy. And if you didn't find statistical significance, say they reported the same amount of efficacy. You know, just plain English, plain language results. Again, not worrying about, oh, your test statistics or anything, just what happened. So the theoretical implications, this is where you're going to be looking at your previous articles in your introduction and saying, oh, you know, comparing it, what was the difference between your results and previous articles or previous research? Did you guys both find statistical significance? If so, why do you think that is? If not, why do you think that is? So I talked about, for this previous example, people exposed to music with pro-social content were more likely to act in a pro-social manner than those exposed to neutral music. Oh, well, this Jacob et al. Is probably going to be talking about, you know, the results found by Jacob could not be confirmed. There are 3 explanations. So maybe Jacob did not find the same thing you found. Here's why I think this happens. Here's 3 explanations as to why this could have happened. What I suggest is read the discussion sections. If you're having trouble with this part, kind of linking it to the theoretical applications, read the discussion sections for some of your articles. Maybe some of the articles you're thinking, yeah, we modeled our project after this article, but we didn't find the same results. I don't really know what to write. Read their discussion section and see when they start talking about the other research, you know, like, oh, this maybe, you know, oh, Jacob et al. 2010 could not be confirmed. There are 3 explanations, and they start rattling off explanations. Kind of look into that and see how they write about it. See what they mention for their theoretical implications. Finally, your limitations, you know, they could have been influenced by the music themselves. So this is discussing your limitations with your research. So regardless, even if you have conducted what you feel is a perfect study, if you find statistical significance, if you did all your data analysis correctly, no one skipped any questions for your participants, you know, everything was done by the book, and you're like, ooh, yeah, this is awesome. You're still going to have limitations, and that's okay. And if you completely botched your experiment, if you're like, oh my God, we totally screwed everything up, we got the numbers all confused, or like, holy shit, we did this wrong, we weren't even thinking about how doing this online was going to influence it because we were anticipating to do this in person, oh my God. Whether or not you're on the spectrum of everything went perfectly according to plan, or you're just putting this together with spit and gum, everyone's going to have limitations. And if you're having trouble with your limitations, think about the type of experiment you conducted. Did you have a between or within subjects design? So again, if you did a between subjects design, you likely conducted an independent samples t-test. If you had a within subjects design, you likely conducted a dependent samples t-test. So you can look back over some of our PowerPoints, some of our lectures, and just kind of look into, well, what are the limitations of between subjects design? What are the limitations to within subjects design? And use those to kind of help you write about it. I don't really want you guys to only stick to your sample size being a problem. If you have a sample size of 100, sample size really isn't that much of a problem. You have a fairly decent sample size. If you want to talk about how maybe you're, I don't know, maybe for some reason the online portion had a problem. Maybe we were anticipating doing like an experiment in person and we had to alter it to make it like this online formula. That could be a limitation. Maybe if you didn't have statistical significance, you could say one of our limitations was that it was online. We possibly could have found more significant results if we had done an in-person study, because you know, the way that we were measuring motivation, or the way that we were measuring maybe peer pressure. Measuring peer pressure tends to work better when you actually have peers around you to pressure you. But if you're doing an online thing, it kind of loses that pertinence. It kind of loses that, I don't know, that urgency of conforming to others if there's no others around you. So just think about your limitations, not only in the sense of sample size, but just think about, you know, your projects and how you design them. Think about your research design if you're really stuck on limitations. Okay. So again, the discussion, what did you find? And did this go with your hypothesis or not? Sorry. So identify and discuss theories. So identify and discuss the theories that were presented by your previous articles in your research and why the results turned out the way they did. So were the hypotheses supported in your works, or were they not? And if so, why do you think that is? Maybe the operational definition you used was different. Maybe they were able to do their stuff in person. Maybe just, I don't know, you know, maybe there were differences between the way you conducted your experiment that they didn't do. You know, this was a project for you guys that was conducted in a few short months, whereas these things that you're reading that are publicized, they've possibly been working on these for years. So keep in mind that it's okay if you don't get the same results. Just make sure you address it. So you can speculate here, but don't make it seem like you know for sure, you know, oh, don't assume that the statements you have are certainty. Don't assume that the differences that you find between Jacob et al. 2010 and your study are certain. But it's okay if you kind of do a little hypothesizing there. Okay, and finally, again, what are the limitations in your study? Don't focus on your sample size. And also don't make this the bulk of your discussion section. You want that to be a paragraph or two. And finally, you want to discuss future research. So kind of think of an idea that maybe you were looking at motivation, providing videos or not providing videos, and you're comparing self-efficacy. Oh my God, excuse me, self-efficacy. You know, you don't just want to say for future research, kind of think of other things maybe you can look at more, the motivation, or other things you can compare with self-efficacy. It doesn't have to be two completely like new variables and you're just winging it. It can be, oh, well, maybe instead of comparing self-efficacy, you know, maybe we can show videos, or maybe the videos didn't work. Maybe we can actually have them do something. Maybe we can have them do a puzzle in which, oh, I mean, this is kind of straying from motivation, I suppose, but maybe self-efficacy more so. This is steering more towards self-efficacy. Oh, I'm going to give you, you know, a puzzle to complete in 10 minutes. And depending on how much of the puzzle you get done, I'm going to either say, good job, or you suck. You are not a good puzzle doer, are you? A puzzle doer. And you can compare self-efficacy that way. So you can kind of think of different manipulations with your variables. You can think of reversing it. So maybe your dependent variable now turns into your independent variable. What would that look like? It's really up to you, but you don't really have to get into super detail. You don't have to, come up with a thesis or dissertation level research for the future. Just something interesting that, hey, would be kind of cool to look into, and here's some suggestions, or here's kind of what I'm thinking. But ultimately, this is how you are going to conclude your discussion section. So in terms of the format or the order of your discussion section, it should be that first part is just, I've talked about it here. That first part is just, what happened in your study? Summarize what your study is without all the results, without like the numbers and the p-values and test statistics. Just state what happened. Did you support your hypothesis or not? The next thing you should get into is discussing the theories and why your results turned out the way they did by, by looking into the theories of previous research and seeing how yours kind of fit into that or not. Next is what were the limitations? So you'll talk about the limitations. And then finally, you'll conclude with the future research. There should be paragraphs in your discussion, and it should be approximately 2 to 3 pages, but it should not be 2 or 3 pages of just one gigantic Pangea of a paragraph. There should be some differentiation there. Yeah, so that is analyzing the results, interpreting the results, knowing once you have that readout on Excel, what goes where in terms of your APA style paper, and then what goes into your results and discussion. So I talked about writing the results and discussion section. If you have any questions, be sure to let me or your TA know. I'm still available if you guys want to schedule an office hour meeting. So if you want to come to my office hours, just email me and we can schedule a Zoom meeting or do something to where if you need to email me questions, of course, but if you feel like it's more so like, no, I need to actually talk to you, go ahead and contact me and let me know. But that is all I have for you today. So thank you very much. I hope you guys are all doing well and you're healthy, and I'll see you later.